Hi students, today we'll solve a very interesting problem from SHM. The question says that there is a block of mass 5 kg moving along x-axis under the action of a force given by the equation minus 20x plus 10 Newton. And it is at rest at t equal to 0 at x equal to 1 meter. So that's a coordinate that is given. What you have to find out is the position and momentum of this block at t equal to pi by 4 second. Okay. So this force is obviously unbalanced and the mass is 5 kg. So applying Newton's second law F equal to ma, we can find out the acceleration is A is equal to force by mass. So acceleration is coming as minus 4x plus 2. So minus 20x plus 10 divided by 5. So here what I'm going to do is that I'll take minus 4 out. So I'll get x minus half as acceleration. So now once you get this equation, it looks like A equal to minus omega square x. But you can see that there is some subtracting part with x. So like parabola, I'm assuming that you have solved already parabola vertex equations in mathematics. So this x minus half is the new variable. So usually what we do or what we get in SHM is that we get A equal to minus omega square x directly. But here you are getting x minus half. So it may be x plus some constant. Whenever we get minus some constant with x plus anything plus minus. So remember that x plus minus, that first bracket term here, this one x minus half, this term is taken as the new x or the new variable, the new displacement. So the displacement I'm writing as capital X. Here capital X is equal to x minus half. So what it implies? It implies that A is equal to minus 4 into capital X. So what's the mean position? We know that in SHM theory that mean position occurs at x being 0. So here capital X being 0, this means x equal to half. So x equal to half meter is the mean position coordinate. Now let us go back to the question. The question is saying that it is at rest at x equal to 1 meter. So where in SHM a particle is usually at rest? It is always at the amplitude. That means at x equal to 1 meter, the particle is at its amplitude. So if half meter is the mean position, this half meter is the mean position and x equal to 1 it is at rest, this means what's the amplitude? Amplitude is the displacement from the mean position to the extreme. So the amplitude A is 1 minus half. So this means half meter. So amplitude is half. Okay, now because A is equal to minus 4x, this means it is minus omega square x. So what's your omega? So omega is coming as 2. So amplitude is half and omega is 2. So these are the data that we got. And the mean position is half. Okay. And also because it is at rest, it is starting at t equal to 0 from the amplitude. So this means it has to come back to the mean position. So from SHM theory, whenever the SHM starts at the end and the particle comes back to the mean position, the equation of the SHM, the displacement capital X, is going to be A cos omega t. If the SHM starts from the mean and the particle goes towards extreme, so if it starts from mean and goes towards extreme, then the SHM equation is x is equal to A sine omega t. But because here the particle is starting from the amplitude and coming back to the mean position, so the x coordinate is A cos omega t. But you remember your capital X is basically x minus half. So it is x minus half is equal to amplitude. Amplitude is how much we got? We have got as half cos. What's the omega? Omega value is 2. And what's the time in which we have to find out the position? According to the problem, it is pi by 4 second. So instead of t, put pi by 4. So we are getting cos pi by 2. What is cos pi by 2? Cos pi by 2 is 0. So half into cos pi by 2 is 0. So x equal to half. So this is the solution of the position. So where the particle is at t equal to pi by 4 second, it is at x equal to half meter. Now we also have to find out its momentum. So mass is already given, it's 5 kg. So we just need to find out the velocity. To get velocity, what we'll do, we'll take the derivative of the displacement. So d capital X dt, the answer will be minus a omega sine omega t. Amplitude, the amplitude is half, omega is 2, and sine omega, omega we got as 2, and time is pi by 4. So 2 and 4, if you it will cancel and it will become pi by 2, sine pi by 2 is 1. So this answer is coming as minus 1. So velocity is minus 1. But because the mass is given as 5 kg, so the momentum P is equal to mass into velocity. The mod value is going to be 5 into 1. So the answer is 5. So this is the momentum 5 kg meter per second. It's the SI unit. So we got the x coordinate, the position, as well as the momentum. And if the time period is asked, from this equation you find out the time period. Because we got the omega as 2, so what will be the time period? The time period is going to be 2 pi by omega, and omega being 2, it will cancel, and time period is pi second. So I hope you really like this question. Subscribe to my channel for more videos like this. Thank you for watching. Tada.